we're thinking about externalities, and we're thinking about how externalities impact a market. We're doing this under this idea that we're talking about market failures. We're talking about situations where the market, left to its own devices, doesn't actually maximize the size of the pie. The benevolent dictator sees that there's something not happening here. So to start with, let's assume that we have a situation without any externalities. Absent externalities, we have a supply curve and a demand curve, and the market finds this output and this price, and that turns out to be the exact same output that the benevolent dictator would have chosen. The pie is maximized. Again, the benevolent dictator doesn't care much about price because the benevolent dictator doesn't care who gets the rent, who gets the surpluses, whether it all goes to the consumers, all goes to the firms, or they split it. Just get the pie big as possible, and that will happen at Q sub 0 in a world without externalities. Now let's do it in a world where we have some externalities. So in this picture, we're going to say, let's introduce a negative externality, pollution. Well, what the negative externality does is it essentially, this is the private production marginal cost, but we now know that in addition to that, there's some additional pollution cost on top. So what we're going to say is that the marginal social cost is bigger. The marginal social cost is equal to, it equals private costs plus social costs of pollution, the pollution costs on the margin. So for any given output point, firms incur private costs of this, but society has this extra cost of the emissions that spill out of the smokestack, or the emissions that fall into the Hudson River, or whatever the case this pollution is all about. So again, what happens in a case like this is that the benevolent dictator says, hey, here's where I think we should stop. We'll call this Q star social optimum. And we know that because the benevolent dictator says, you know, when you go past that output point, Q star sub social optimum, marginal real cost to society exceed benefits. The firms don't care. The firms see benefits exceeding costs. So they're going to keep producing more. But from society's point of view, when you add in the pollution costs on top, the sum of all those marginal costs, pollution plus production, is greater than value. The pie is getting smaller. Each time these firms add an extra unit of production past that level that the benevolent dictator would like to see, there's an excess of cost greater than value equal to this, and it goes all the way out to the market. They don't see those costs. The stuff goes out of their smokestack and it's gone. It just floats away. Or the stuff goes out of the pipes into the river and it's gone. It just runs down the river. But from society's point of view, they're very real costs. This area is called the deadweight loss triangle. Not good. Not good. It's how much the pie has shrunken. Now, what we have to do in situations like that is we have to ask, what's the policy option? What is our response? We know that Q star sub social optimum, because it's a negative externality, Q star sub social is less than what the market puts out. The market is overproducing. I'm going to write it out. The market is overproducing because the private participants do not see the negative externality. What's our options? Well, we've tried a lot. We talked before about how the EPA was put in existence so that they could make firms recognize they can't just use up our scarce air. They can't just use up our scarce rivers. Okay? So we've had situations where the EPA's choice has been sort of direct controls. They've just sort of passed regulations that say everybody has to produce half as much as they used to. We know that in cases, for example, right now, in countries that are having their first brush with these, growing countries like China, China had a recent sort of a really bad series of days in Beijing, and firms were just told not to produce. The factories were shut down for 3 days. Cars were kept off the road for 3 days in an attempt to try to stop the emissions into the air and to get the smog back to a less dangerous level. We've done that in the past. We've also tried to impose taxes on output, taxes on emission. These have been more or less successful. Recently, the approach has been something called cap and trade. And in a cap and trade system, the key is, first, you need to derive the cap. That is, the amount of emissions, it's really pollution, and it's hard to say the amount of pollution, the amount of emissions you think is appropriate. The answer here is not zero. I mean, it is. Some products like spent nuclear fuel rods, you can't just dump them in a ditch bank. Probably zero is right for that. Dioxin, you don't want to put too many drops of dioxin in a river. It can take care of just a few drops can be incredibly harmful. So there may be a few products where we don't want any, but can we tell firms that they can't have any smokestack, any emission come out of their smokestack? Well, we could, but we don't know how to make steel without that. Okay, the law of conservation of matter and energy means that when you're going to put these processes under high heat to make steel, well, emissions are going to come off that. And no matter how you try to control it, you can't stop it all. Okay? And so some of these things we just can't get to zero, but we can start to limit them. So we come up with a number that we think is the right amount. And then the second step is that you issue permits that allow X amount of pollution, where the cap is equal to the sum of all those permits X sub I, for I equals 1 to N firms in this particular offending industry. They all get some permits that they have to use for the right to kick certain particulate matter in the sky. I know, it sounds like we're selling the right to pollute. And in fact, we are, because it's just economically infeasible to not have any. So we're going to find out how much we think we should have to keep our air clean and healthy. And we're going to give permits of that amount. And the third thing is we are going to allow trade of the permits. Now, we have been doing this in the sulfur dioxide market now for over 10 years, over a dozen years. The sulfur dioxide trade is just this type of situation. There's an auction in the spring of a certain number of permits for next year. People can go out and buy these permits. You can also sell them during the course of the year. Why? Well, sometimes after you've already acquired some permits, you'll suddenly win a new contract and you realize that you have to have your factory run instead of 2 8-hour shifts a day, you need 3 shifts a day to try and get all the product out for this contract you want. Well, if you're going to be running your factory 3 shifts a day, that means you're going to be putting more particulate matter out the smokestack. The only way you can do that is to go out and acquire some permits. And so there is an active market in these sulfur dioxide markets for people to go out and acquire more. Sometimes people invest in cleaner technology, which means they don't have to have as much as they used to have, and they'll sell some on the market. That's where all the buying and selling happens of this. To an economist, this is a great deal, because what this does is the market price will float around for those permits. It gives everybody an incentive to do better in terms of making their factory cleaner, but it allows those who have to have it on the margin the ability to go out and get some to put a little more out. Of course, they're putting a little more out, and you can say, well, that's bad, but the only way they're doing that is taking a little less pollution. There's going to be a little less pollution from some other factory, from some other firm. The sulfur dioxide market was geared towards a goal where the government said we can't just go from here to here in 1 year. It would just be gut-wrenching for the industries. So each year we're going to lower the amount of permits. Each year we lower the amount of permits gradually so that over a couple decades we'll have moved this industry from here down to here, where here is a level that we think is safe, less damaging sulfur dioxide, less damaging acid rain effects for the big timbers in the Northeast, all sorts of other positive effects. Right now, countries are talking about carbon taxes. This would be the same type of system, a system where we would look at carbon emissions and have a cap and trade system put in place.